Good evening all, and welcome to Timber Development UK's University Design Challenge 2022, Southside Hereford, which is organised in partnership with Edinburgh Napier University, NMITE, which is the Newman Institute for Technology and Engineering, and the Passivhaus Trust. And this challenge is for students and 2021 graduates studying built environment subjects at UK universities. And this series, which you're tuning into tonight, is running alongside the challenge to inform our future professionals, as well as the wider audience who are considering using timber in construction. So Southside Hereford Student Challenge is interdisciplinary, cross-university, and it's a team challenge to design, engineer, specify and cost one single community building from timber to passive house standards. There's a budget of 1.6 million and they're looking for up to 800 square meters. But I've been assured it can be designed to passive house from timber for that amount of money. And here's your site. It's on a greenfield site on a hedge line. Please ignore the sketch. You can design whatever you like. It sits on that boundary, and it is formerly parkland to the right where the football fields are going, and farmland to the left where Growing Local are going to put in their market garden and vegetable beds. If you're regular users, then you will have, you know where everything is, but we record these and we put them up on our dedicated YouTube channel. We have a TRADA participation website, and obviously you've got here via Eventbrite bookings, and I will put the links in the chat later. And so tonight we are bringing timber into the digital age, and our speakers are Gary Newman from WoodKnowledge Wales, Luke Whale from Staircraft, Mila and Gareth from Stora Enso, and unfortunately we've had one apologies tonight from Jamie Johnston, who's been unavoidably called away. And I introduced you all upside down and back to front because first of all we're going to hear from Gary, followed by Mila and Gareth, and then on to Luke. Now we do have time to ask questions after each speaker, so if you'd like to put them in the chat, and then we'll ask them to that speaker, and then at the end we'll have a bit of time for like a round table chat. So with that, I'd like to stop sharing and hand over to you, Gary.
Thank you, Tabitha. I don't have any slides. And you'll be pleased to know I'm only speaking for 5 minutes as a scene set, so you won't have to put up with me for long, but I'm happy to stick around for questions at the end or whenever. So we had a little bit of a chat about engineers and architects at the beginning. I'm actually an engineer by training, but have been involved in really research and business for most of my career. I'm the chair of the Alliance for Sustainable Building Products and the chief exec of WoodKnowledge Wales. And I'm really going to talk to you a little bit about WoodKnowledge Wales as by way of a scene set. But I do feel like I have a little bit of imposter syndrome because I'm certainly not a digital expert. I'm too old for that. In fact, I had a very earnest conversation with another boy when I was in sixth form in school, and I can remember it really clearly. I was saying, home computing, that'll never take off. So what do I know? Anyway, so, but Tabitha persuaded me that the approach WoodKnowledge Wales takes to driving change in the forestry, manufacturing and timber construction sectors would be a good starting point for this really interesting event. I'm very pleased that I got the invite because it's an evening, and if I hadn't, I wouldn't have connected in. But I really need to understand this space better. So thank you, Tabitha. And I hope you're right that it is a good scene set, but it's not for me to judge. So I think one of the main points of this evening's event is that the timber industry is not one industry. It's lots of separate and competing industries, whether tree growing or processing, manufacturing products or creating buildings. These industries often do not work well together, particularly in the UK. But there are huge quality and efficiency gains if this could be changed. And digital information, big data, if you like, I think is set to play an increasingly important role. So I'll tell you a little bit about WoodKnowledge Wales and our approach. Let's start with the vision. So I'm based in Wales, as the name suggests, and we're seeking the transformation of Wales into a high-value forest nation. If there's anyone from Wales here, you will know that Wales is definitely not that. Wales is essentially a sheep, beef, and dairy nation, and a steel nation historically. Steel production is a big part of our history. Certainly not trees. Trees are not seen as part of our cultural heritage. But what is a high-value forest nation? So for me, a high-value forest nation is one where we have large, well-developed forestry covering a lot of Wales. Wales has about 15% forest cover. European average, I think, is somewhere in the mid-30s. So Wales, you could say, is largely deforested. Nearly all the timber we use for construction is produced outside the UK. In fact, nearly all the timber we use in the high value products is from outside the UK. The UK is the second largest importer of wood-based products in the world. And in Wales, growing trees is seen by farmers as a sign of failure and inability to produce valuable products. So it's not culturally seen as an exciting land use choice. Despite that, we now have huge afforestation targets as part of the climate change issue, and so we are going to have to change that. So a high value forest nation is also a nation where trees are converted into engineered wood products that society will almost certainly need, will certainly need to meet the decarbonisation targets that are being set globally. Timber is a key industrial resource for that. And really in Wales, we don't make that many of the high value engineered products that we're going to even make some, but not that many. And it's also, we want to see a Wales where the construction industry is based upon low carbon sustainable approaches. That means a lot more use of timber. So essentially, we're not just shooting for new industries, we're talking about a significant transformation of Welsh society, driven in part by the climate change obligations of the current generation in Wales, but it's also a viable economic and strategic opportunity. And Welsh Government are in the process of developing a timber industrial strategy to really push us further along this path. So I'm sure all of you know that the role of trees in climate change is to take carbon out of the atmosphere. And then when we use that timber in construction, we're storing that biogenic carbon and preventing it from going back into the atmosphere, at least for a critical period of time that we're entering right now. So what are we? So WoodKnowledge Wales is an independent for public good membership alliance. So we're not a trade body. We don't represent our members. The only thing we represent is this vision of the transformation of Wales. Our members include forest management companies, sawmills, manufacturers, architects, housing associations and housing developers, and many other associated businesses besides. So we're creating this big collaborative network with a shared mission. Our approach, as the name suggests, is based on creating and sharing knowledge. We bring people and organizations together across the whole supply chain from forest to building to better understand the barriers and opportunities associated with the transformation to a high value net zero society. We run multiple knowledge sharing networks known in Wales as communities of practice. We have an example would be nearly all the timber frame manufacturers based in Wales are in one network. We also have a joinery network and small sawmillers, housing associations. And then we seek to amplify best practice through case studies and stories. And we create guidance on all sorts of aspects related to the growing of trees, the processing of wood, and the building of low carbon buildings. But if we're to truly succeed, the collaboration between grower and processor, between processor and manufacturer, and between manufacturer and the building client is going to have to massively improve. We need to get modern and quickly. In the UK, construction and forestry are both very conservative, kind of old school industries that really are in need of being brought into the 21st century. So by way of drawing things to my conclusion, I hope that the digital age that we're talking about this evening, as in the title, will provide us with the tools we're going to need to collaborate better, to modernize these old industries and make good things happen faster, at lower cost, and with greater certainty of the outcomes. So let's hear what the experts have to say. So thank you, Tabitha.
Thanks, Gary. That was perfect. So, as I said, setting the scene and using Wales, as a very small nation that can change maybe more quickly than other nations. And yeah, really good to see that happening. Can I hand over to, if there's any questions, please put them in the chat. We put the WoodKnowledge Wales link in the chat. But otherwise, I'll hand over to Gareth Mason and Mila Duncheva from Stora Enso.
Thank you, Tabitha. I'll just try and share screen. Hopefully, I'll pick the right one. Can you see that?
Perfect.
Yeah,
absolutely perfect.
So yeah, hello everyone. Just to introduce myself, I'm Gareth. I'm Sales Director of Western Europe for Stora Enso. So my role is to look after all sales and business development and live projects on this side of Europe. And today I'll be presenting with Mila. So I don't know, Mila, if you'd just like to introduce yourself as well.
Yeah, hi everyone. I hope some of you saw me on Tuesday. I'm Mila Duncheva, and I'm very happy to be the UK Business Development Manager for the UK and Ireland, because that means that I get to speak with architects, engineers, developers, construction managers, all about the benefits of COT and how do we actually implement it in real life projects. So yeah.
Brilliant, thanks Mila. So if you'd like to start us off.
Yeah, of course. So for anyone who may have missed the Tuesday talk, I've got a refresher here on Stora Enso building solutions. So our products can be applied in a whole range of contexts, and the examples you see here are only some, and by no means the limits of your imagination. I mean, just look at this special building and its brilliant biomorphic design. I know some of you are quite interested in this type of parametric modeling, so just be aware, even though you see the products as sheet material, the possibilities in terms of design are literally endless. And yeah, this is the material itself. So within Building Solutions, we mainly manufacture two types of components: cross-laminated timber, which can be manufactured in panels up to 3.45 by 60 meters. It then cuts CNC for bespoke applications. You're going to hear about that in a minute. And also laminated veneer lumber, which can come either in sheets for use in walls or in beams and columns form. A little tip for transportation on the COT: if you want to keep your transportation costs down, I know that's a big important part of this challenge, preferably go for 2.45 or 2.95 widths of the COT panels. And just because you see them in panelized form doesn't mean that's the only shape and form in which they can be bought. Indeed, as you can see here, the COT and the LVL, the main difference between the two is the size of the lamella. As you can see, the LVL has much thinner lamellas, whereas the COT has thicker lamellas around 20 mil, etc. So yeah, they can be bought as rib panels as well as in sheet form. And again, another tip on when to use COT rib panels versus when to use COT panels: around about the above 7 meter spans is when the rib panels made out of COT become more cost competitive than the pure sheet COT materials. So that's another good tip for you. And any stairs you've got, those can be CNC'd out of out of COT to ease installation on site and make sure that the people who are working on the building, whose safety is really important, can have a secure staircase to work from straight away rather than having to navigate the rather dangerous scaffolds. And in addition to that, we add a lot of value to those products in the factory, all the way from hydrophobic coatings, UV protection, termite treatment, or other, if similar, lifting devices can be pre-fitted, as well as fixings can be fitted, again, adding those marginal gains in terms of on-site productivity.
Thanks, Mila. And just to talk maybe a little bit about the different types of CLT that we offer, there's usually 3 different levels of visual quality of CLT, and those being here on the left. Non-visual is pretty much always clad in plasterboard, so it may have things like blue stain, a higher number of knots, it might have knots falling out of it, and obviously that's okay because it's intended to be covered by plasterboard. The middle industrial quality is it's an exposed visual grade product, so it's meant to be left exposed visually, as you can see in some of these images here. And the difference there is that there's less knots, it's dried to a higher moisture content, so it's less likely to crack or open up in the future in terms of where the grain splits. And yeah, in that sense, it's slightly more expensive. So these 3 levels have different levels of cost. Non-visual is the cheapest, industrial is slightly more expensive, and then we have VI, which is the highest quality, and that's really reserved for quite high-end projects. What we find, and obviously VI being the most expensive, and what we find is there's a majority splits, usually around about, in terms of sales, about 60% of the buildings, or the buildings that we sell, are usually non-visual, around about 40%. Sorry, about 30% would be industrial middle quality, and then only about 10% as VI quality. So I would say most commonly is non-visual, and where you want it exposed, most common is IMV, the middle quality. We also do have some special finishes like larch and silver fir and these kind of products, but most people internationally opt for a normal standard spruce finish, and all of our CLT is made from majority of the spruce with there's a possibility of a small amount of pine in the internal layers. In regards to where our CLT comes from, it obviously starts in the forest, and all of our timber is sustainably forested. And the way that we manage that is by working and only buying from forests that are PEFC or FSC certified. And these 2 certified bodies ensure that regulations are followed in the forests where we source our materials. For instance, things like when a tree is harvested, another tree is planted, or at least 1 tree is planted. Often it's 2 to 3 trees are planted in the place of 1. Also, only a certain amount of deforestation at a certain time, only a certain amount of harvesting for, like, in the time of year. And in general, looking after the biodiversity of the forests as a whole. It's very important that we keep our forests strong and healthy, because if not, then the entire forest yields little results in the future. So to ensure that we have a strong future of timber supply, we have to keep the forest very strong and also growing. Stora Enso ourselves are actually one of the world's largest private forestry owners. So we own a number of forests all over the world. The majority of our forests are based in Sweden and Finland. And you can see last year, or not last year now, but in 2020, we grew around 13.5 million cubic meters of timber from forests. But we only harvested 9.5 million of that. And that's a very key aspect. It's always about growing more than you harvest. But overall in 2020, we planted around 62 million new trees, and we do that pretty much on an annual basis, year in, year out. And that just goes across the entire forestry stock. So outside of just Stora Enso's forests, Europe is a very good region of the world for growing timber. And in fact, because most of the forestry is covered by PEFC or FSC certification, we've actually seen growth in the forests. So over the last 30 years, the standing stock of timber, or basically the timber available for use in harvesting, has actually increased by 10%. And that's a testament to the fact that we're constantly, for the last 3 decades, planting more than we're actually using. So even though we're using more timber as a globe, we're actually also having more timber available to us in the future. We aim to use all of the tree, and in terms of CLT, only a certain percentage of the tree is used. So we potentially use it, or possibly use all the middle boards, so the inside of the trunk and the boards around the outside. But the rest of the tree, like the bark or the outer edges or the waste, that goes into other products such as lignin, or byproducts such as biomass waste pellets. So we really aim to try to use every single part of it. And in fact, last year, 2020, Stora Enso had a waste utilization of 98%. Thank you very much, Tabitha. In regards to the utilization of a tree, essentially for every tree we use, only around about 33% of it becomes CLT, but the rest of it goes off into other divisions. And as I say, it does get fully utilized. Then if we talk about a little bit about our production facilities, we have 4 CLT mills and 1 LVL mill. 2 of our mills are based in Austria, 1 is in Sweden, and our newest one, which is coming online this year, is based in the Czech Republic. And we aim to use the trees that are within around about 150 kilometers of our factories. We actually have about 18 factories worldwide for different wood products, but for CLT, we always aim to try and use the trees that are around the factory's location. By the time that our factory is complete, we'll then be looking at about nearly 400,000 cubic meters of CLT we'll be able to produce next year. So in regards to the digital technology of that, obviously before these models come to our factory, there's a design element, and this is a very BIM-led design environment. So we start off with the 3D model, obviously from the architect's planning and the architect's proposals, and that then moves into engineering design. And it's not always using FEA technology, but this point in engineering is where we're looking at acoustic performance, fire performance, structural loads, structural spans, deflection limits. And at that point, that's where all the timber is sized. And once that's gone through engineering and we know the sizing of the elements, it then moves to a more manufacturing-based model. And that's fully detailed, split, numbered with all things like, for instance, M&E openings. So those M&E openings are very accurately placed into the 3D model as a collaborative BIM model between the architect, the engineer, and the client and ourselves. And you can see here the kind of accuracy in the bottom left that we achieve around M&E openings. This is a highly precise millimeter precision process. And as long as the 3D model is correct, it's manufactured within a couple of millimeter tolerances of that. And you can see here just a couple of examples of where we start with the architect's model, what the kind of manufacture model looks like that is sent to us, and then the final buildings we see here on site. And there's usually very little difference from the BIM model to what's finished on site. When we turn to the actual digital technology itself in the factory, obviously we start with trees, and those logs are split down into planks. But the whole process is completely computerized. So we monitor every plank that comes in, and every CNC process in the factory is controlled by our main control center. And then these panels are created and then CNC cut, and they move on into the loading hall. So to give you a quick, hopefully this video works okay. But what happens is we make large sheets of timber, which are then layered together in a press. And once they come out of the press, they're now solid mass timber panels. We run those into our CNC machines. And you can see here the CNC technology that's being used is actually exactly the same 3D model that was designed throughout the design process. So that model that's created by our partners is exactly what these CNC machines are using to cut the final product. You can see here the kind of small amounts of waste that we tried to get, and then it comes off into the loading hall to be ready to be delivered direct to site. In terms of CNCing, we have 3 Hundegger machines in each factory, and they are pretty much capable of making any kind of cut, angle, recess that you need. There are some limitations, but in general, you're not really too restricted about the kind of CNC processing that's available. But it doesn't just stop there. Obviously, that's the model for our production factory, but that 3D model is used digitally throughout the entire build process as well. And you can see here some examples of the kind of GA drawings that we would use on site. So this is for the full setting out on site and installation on site to make sure the dimensions are correct and the panel numbering is correct. That model is also used for connection design. So the model itself is used to be able to count fixings, screws, connectors. but also importantly, the full sequence of the build is decided at this stage in BIM. So we know exactly what panels first, what's going to be installed in what order, and what panels are going to be loaded on what lorries. So that 3D model is also then used to generate the loading order for the lorries themselves. So when the lorries arrive on site, the panels are stacked, and the first panel that you need is the first panel right on top of the deck, and that makes it really quick for the site team to build. And of course, we do a number of 3D generated lorry loading drawings to fully understand when that comes to site, how it's going to be loaded, and how they need to offload. That 3D model is also used for temporary works. So when you obviously land a panel or a wall panel or any panel, you need to temporarily prop that until it's fully fixed with all the other panels around it. And so that 3D model carries all along in through temporary works, health and safety, and design guidance. So it really helps form things like edge protection, ordering, and where escape stairs need to be, and those kind of topics in regards to site installation. Also now we're carrying on that digital model, which is essentially a digital twin all the way onto the building site itself. So it's no longer 2D drawings anymore. They're obviously created. But now we have this app called CLT360. It's a Stora Enso app where the site managers can have, whether it's a phone or a tablet, scan the panel. That panel has a QR code, and it will show them then on a 3D model exactly where that panel goes, all of that panel's properties, how it fits together, its connection detail, its sequence numbers and things. And we're finding this is now incredibly common on all mass timber sites. It's really taking the design office onto the build site itself. And this app can also record installation data and send that back to the office. So now the design office is no longer cut off from the site. They can actually see real life statistics of what's been built on site. I'm not going to show you all this video because it's quite long and I'm a bit conscious of time. So I'm just going to skip through a little bit, but this is a great example from our partner Urban in the UK. And this kind of shows the level of BIM modeling compared to what's delivered to site. This is a Navisworks model where it fully models in not only time, but also costs, so that it can be used for programming. So when you're programming your build by using some software like Navisworks or just effective planning, you know exactly how many days it's going to take to build, how many hours, how many panels per day. Also, if we zoom in a little bit here, you'll be able to see the comparison between this live twin BIM model versus what was delivered on site. And I think there's another great example of that just moved on a bit here, which is, as you can see, all fixings are counted, you know, every single number of screw that's in the building. And because of this, there's less waste, because you know every single connection and every single screw, the quantity takeoff and the costing for that quantity takeoff can be very accurate. This project itself also has, you can see these purple boxes, that was bathroom pods. So these were fully finished bathroom pods dropped in during the build, and that was sequenced with the bathroom pod provider to ensure that, again, speed of build, fully finished bathroom pods during this stage of construction. I will skip a little bit forward, but you can see here the kind of CNCing that was required for some connections in the model, and you can see how accurate that is on site when it's made. I'm just going to skip on a little bit further to maybe the full time lapse of a build. As you can see here, this is where we have lorries arriving on the left, and then those lorries are very quickly assembled on site. And this is a wet trade free, dust free environment, so it's incredibly safe, incredibly accurate. There's very little remedial work to be done on site because it's all done, all the errors are found in the 3D model before it's found on site. It's also one of the quietest forms of construction, but more importantly than anything is speed of build. So a building of this size, typically all of the walls on the ground floor and the floor panels above that would be built in around about a week. So a building of this size, 8 to 10 stories, is usually built in around about, say, 8, 10, 12 weeks for this size of build. And that kind of speed is common across all different types of buildings. Houses might be built in about 4 days. Very large buildings might be built in months quicker than more traditional construction. I'm just going to skip on to the next one. This is the finished building in situ. So again, this was by our partner Urban, and this was fully completed a couple of years ago. It's in central London. Another quick time-lapse example for you. This one was in Australia. This was built for Lend-Lease, 25 King Street. This is a 10-storey high office building, and you can see this form of construction is quite different because it's an office. This was a beam and post construction with CLT floors. But what's, I think, an amazing example here is how they were building the cladding at the same time as building the building. So this building was made watertight, and the follow-on trades were allowed to start on the ground floors even when the top floors are still being built. And that the result of that was being able to squeeze that program even quicker. So a really big key of mass timber building is that the speed of build. That's where the majority of the cost savings are made. And the quicker that you can program and the more efficiently you can program, the better overall for the costing of the job. And with that, I will hand over to Mila.
Yeah, thanks, Gareth. Great example. I really appreciated the lack of scaffold as well. You could actually see the building as it went up. That was brilliant. Yeah, so now I've got the honor to chat with you about Ellerslie Road, which is a project we did with our partners Urban for CCG here in Scotland, where I'm based. So a little bit about the project. It is a 7-storey cross-laminated timber residential building for mid-market Trent, and it is, as far as I believe, the tallest timber building in Scotland still. So next slide, Gareth, please. And here you can see the context. It's located all the way out west in Glasgow, pretty much near the "You're now leaving Glasgow Council" sign. If you see that, that means you're very close to this Yoco building. You should take a detour and go have a look. And what's quite interesting is that you can see the panels going up. So this building utilized as much CLT as possible in the superstructure, including all the internal partitions, etc., were all made using cross-laminated timber with the openings pre-cut, which was especially useful not only for the windows but for all the boiler connections as well. Next slide, please. And so here, as a result of using as much CLT as possible, this building actually removed 757 tons of carbon dioxide equivalent from the atmosphere. And as you can see here, that includes any considerations for the transportation and for the transportation carbon, as well as carbon that was emitted in the production. So the bottom line, the net result is 757 tons of CO2 and estimated energy bills of £296 per year. Some people may be paying that much per month if they live in a big mansion, but these people pay that per year, which is really important, especially for tenants from housing associations. And yeah, I had the great pleasure to go on site every week on this project, and not a thanks to that to Robert Hairstown, who's in the room. So I investigated the productivity and on-site efficiency of the Yoco building, whereas colleagues from Edinburgh Napier University at the time investigated, measured the air tightness, the U values, and indeed in that respect, it all performed really well. But in terms of productivity, so there's a few ways to look at it. One way, one unit of measurement is waste materials. So approximately 590 tons of CLT were installed, out of which during the superstructure installation, only 200 kilograms of waste were produced, which gives us a materials efficiency rate of about 98.5%. So really low in terms of waste materials on site. And we already heard that the waste materials are very low in our factories as well. So it's not like that waste is moved somewhere else. This is indeed the situation in terms of reducing waste materials. Next slide, please. And that efficiency was also observed in productivity when it's measured in labor hours. So in a matter of a few weeks, I forget how many weeks exactly, but it was very rapid, and it was all the CLT was installed only by a team of 5 people who you see here. They're on the screen, very lovely and friendly people. But what's quite interesting is that the whole superstructure installation accounted for only 3% of the labor on site, whereas the finishes, internal and external, accounted for, as you can see, more than about 60%. 50% of the works. So a lot of the time we talk about optimizing the MMC system. Well, how much more is there to optimize? It's only already 3%. So really efficient in terms of labor utilization, which is very critical in the current situation of a skills crisis, which we're experiencing in the industry. Next slide, please. Our efficiency doesn't really stop in the construction stage. Indeed, we have a circular business model at the heart of all of our operations. As you can see here, that includes stuff like creating new batteries out of trees. But next slide, please. It's also transferred to circular building designs as well. So this is an example of a design for manufacturing assembly plus disassembly school near Cambridge, where the school was built at a certain size to accommodate the local community. But because there's a whole village being built in the local area, the school will be expanded and adapted in the next 5 years to accommodate more people as the surrounding village grows. And we're also a partner in the In Future Wood project, where we're looking at how can we actually reuse material that's been weathered during construction, during use from building sites. Next slide, please. And I know a lot of you have questions about costs. You're wondering about costs. And previously I spoke about how a lot of the functions you're summarizing in your designs are similar to the functions you'd observe in a school. And this is a study by Turner and Townsend from 2021, which compared the urban school, which is made out of COT, to a benchmark which takes the average of 7 steel schools. And long story cut short, the COT costs 33% less per meter squared than the steel benchmark. So yeah, there's your answer in terms of the cost viability of COT. And with that, Gareth and I are very happy to take any questions on our contact details. Thank you very much, and we wish you good luck. Any final words, Gareth?
No, just good luck to everyone. So it's a really amazing. I love working with TD UK on this challenge, and yeah, very good luck to everyone who's involved.
Brilliant, thank you, Gareth and Mila. And I know Stora of Enso have been a sponsor of the student challenges from way back, and really appreciate your support. There's a couple of questions, so I'm going to ask them while they're here. One I'm going to read out because it's come directly through to me. And it says, for Stora Enso, Gareth. Gareth mentioned they coordinated with architects. From which stage in the planning? So I'm guessing that's the architectural stage.
Yeah, so in terms of stages, we would always advise people to start engaging with our partners as soon as possible. So even as early as REBA stages 0, 1, if you're already thinking about using mass timber, it's important to engage with supply design and install companies as soon as possible, because one of the problems is that further down the line, if you take a job that's been designed for steel and concrete and then try and change it to CLT later on, you lose out some efficiencies. So really having a mass timber company or supplier being involved in the early stages, the greater the efficiencies. I'd say typically it's usually after planning in general, ideally sooner than that, but usually once it's gone through planning permission and it starts going out to looking at definitely before REBA stage 4 technical design. So usually I would say around about REBA stage 2-ish is where the architect should start engaging.
Oh, brilliant. There's a second part to the question. So the BIM coordination offer, does that come as a standard service, or is there additional costs, including obviously the app that you talked about?
Yeah, so our partners who provide supply design and installation, it's important to point out that Stora Enso are a manufacturer. So we're mainly a supplier to supply design and installation companies. So when it comes to BIM, that's usually done by the supply design and installation companies themselves. And when they create an offer, that's part of the design fees and the design package itself. I think it's important to be clear that they are not usually employed for BIM coordinators for the entire project. Usually especially for big projects, there is someone who is employed as a BIM coordinator. But in terms of collaboration, everyone's sharing that same BIM model. So, and they're all kind of responsible for their own model. So usually the mass timber suppliers or supply design and install company, they would be responsible for the timber superstructure part of the BIM model, and they would collaborate very closely and they would create that model. But usually there is a BIM controller employed somewhere by the design team rather than the suppliers.
That perfectly leads on to a second question we've had, saying, is the 3D modelling software truly so accurate as to eliminate or highlight errors before construction? And I'm guessing that's what your BIM coordinator's job is.
Yeah, I mean, in terms of accuracy, obviously BIM itself is incredibly accurate because it's down to less than a millimetre, point something of a millimetre accuracy within AutoCAD. Where the tolerances do lie is in the CNC machines. So there are tolerances. There's around about 1 to 2 mil tolerance on average on cutting, depending on the types of cuts. So in terms of accuracy for the finished product against the model, we're talking about per element 1 or 2 millimeters. What's very important though is when you assemble lots of components together, you also get tolerance in how you join them together, and site tolerances is kind of standard. I think a normal site tolerance to work to is plus or minus 5 millimeters. And the good thing is there though, it can be planned for and is designed for. So the connection design between panels, for example, can have a small gap, and that allows you to close or open the panels a little bit. So yeah, fair enough to say that it's not like nanomillimeter to the BIM model, but within 2 to 5 millimeters on site versus in the model is usually good enough and close enough.
Fantastic. Thank you both. And obviously once you get moisture into it, then obviously the expansion and contraction, yeah, you can soon lose that 5 mil tolerance. Any further questions, please put in the chat, and Gareth and Mila, you will hopefully answer them at the end. And I'd like now to hand over to Dr. Luke Whale from Staircraft. Luke, the floor is yours.
Thank you, Tabitha. Hello to everybody. Good evening. My name is Luke Whale. I'm a civil engineer by training, and as soon as I graduated, I went straight into timber. So I've specialised all my life as a structural timber engineer, and you can tell from the colour of my hair that that's a long time now. Just to give you some idea, I've chaired the British Standards Structural Timber Committee now for over 30 years. So, there's very few people that do structural timber for a living, and I'm one of them. I'm hoping that a lot of people in the room today are going to follow me and build the network of engineers that know about timber in Britain. That's what we're all hoping for, because I've only got a few years left in me, so I need you guys to come on and take over. I've worked in the industry all my life as an engineer, but I've specialised in product innovation and research, always in companies, not in academia. But my current job is with Staircraft, who are a very large producer of stairs, structural stairs, the biggest stair manufacturer in the world, in fact. And they also manufacture I-joists and supply floors. Around 1,500 stairs per week are made at Staircraft and supplied into the UK. About 500 floors, residential floors, and about 3,000 doors are supplied. And that's all into the residential housing sector. So that's all the big builders that we know and love are taking product from Staircraft. So we don't do commercial work, we're doing residential work. But our interest is in automated production and automated design. And so my talk tonight is really on automated design, and that's something that Staircraft is very interested with, a number of products that we have to ship every week. I should also say that as a hobby, I'm a beef farmer. I have a small holding down in Hampshire, and I have about 40 head of cattle. So there's another side of AI that I'm also familiar with. I could talk about, I've got 2 presentations on AI. One is on artificial intelligence and the other one's on artificial insemination. Tabitha, I guess you want the one on artificial intelligence. So that's what I'll do for you. If you ever want the other one, then let me know and I'll be glad to oblige.
Thank you, Luke. I come from a small holding background, so I know exactly what you're talking about.
Oh, okay. So I've got little Dexter's cattle, which you may know, the little
I do.
Little Dexter's.
We have Herefords.
Okay, so I'm going to share my screen. Hopefully I am.
And the right presentation.
Okay, get the right presentation. Yeah.
And you just need to make it full screen, please.
Yeah, so I need to do the slideshow from the beginning. Hold on. Okay, now
Perfect.
You're seeing that. Good.
Yes.
That's good. So I'm technical director of Staircraft, which is my day job, if you like, looking after design and innovation and software. But we were the client for an application called DAISY, which is an acronym for Design AI Systems. And I think we were the first company to actually commission software to use artificial intelligence to design structural products, let alone timber structural products. I don't think there's any other software around at the moment that is using AI for designing structural elements. But we did that, and we're now proud owners of that software, or partial owners of it, and we're proud to use it every day of the week at Staircraft in the UK. I'm going to talk about DAISY, its background and how it was developed, how it works, and give you a little demo, if you don't mind, over the next 15 or 20 minutes. So DAISY is a company which is being set up as a company in its own right. It's centered in Canada. It has an office in the UK as well, in London. It's a merger of two disciplines, really. Construction technologists, people like myself and my managing director at Staircraft, Andy Hamilton, who is a businessman and into product factoring and design. People like myself, an engineer by background, and people from a company called Brainpool, who are specialists in artificial intelligence software. So DAISY is a conglomerate of those two expertise, formed a company which is now, as I say, operating in Canada, and is looking to exploit DAISY throughout the world, really, with the ambition to try to make timber design easier and faster. One of the things that I think is a bottleneck to timber expanding its application is the complexity of design. I know as a engineer myself that you learn steel and concrete in college. It's very rare to have timber taught to you unless you go to a specialist university like Napier. And there are a few others like that, but too few. So most engineers come out with nearly no timber engineering experience, and therefore they're not going to specify timber that readily because it's unfamiliar to them. And we're trying to make it automated and dumb it down so that anybody, any architect or any engineer can use software to get them where they need to be quickly and easily. So I think without this type of software, timber will struggle to realize its true potential in the world, in use in construction, because there literally aren't enough technicians or engineers to serve the demand that could come. Okay, so we submitted and won. I'm pleased to say we submitted and won an award last year for the Coins Grand Challenge, which is they're a software company who invite innovative new ideas using any construction technology to come forward into a competition. I'm glad to see we won that award last year, so that was nice. And the picture on the screen, that's not me, that's one of my colleagues who works in Canada as the product manager. Okay, so in a nutshell, DAISY is automating structural design. It's effectively framing floors at the moment with structural components automatically. It's undertaking structural design to the relevant code of practice, and it's helping to streamline the decision making to come up with the most effective solution, which is fit for design as well as manufacture and supply to site. That's its objective. We've started off with structural floors because that's something that is very close to Staircraft's heart. But we intend this year to expand the application of DAISY into other elements of the building, starting with CLT, floors, walls and roofs, because we've seen the massive uptake in interest in CLT, and also into prefabricated wall elements like frame wall elements, timber frame, traditional timber frame, if you will, and truss rafters, for example, are another application that we'd set our sights on in the future. So DAISY one day will hopefully become a hub for all timber engineered products to be designed automatically without intervention by specialists such as myself. So I'm trying to write myself out of a job, frankly, and I think I'm okay, but I can get to retirement before this happens, but that's not very many years' time. Okay, so DAISY is already being used day in, day out by Staircraft, who are probably supplying 15% of the residential timber floors in the UK to all the major house builders. As I say, there's a typical floor on the left-hand side of the screen using I-joists. DAISY can design with solid timber joists as well, and all other engineered wood products, including LVL or glulam and so on. And we're getting it, we're about to launch it in America. Staircraft is using it exclusively in the UK. They bought a license to use it exclusively for a while. But in North America, we want to launch it into the mainstream market for engineers and architects to use. And so I'm going to give you a demo at the moment, which was geared up for the North American market. So the benefits, as I see it, is that it's trying to produce code-compliant, production-ready designs, and also to optimize the space. So you'll know that in a floor, there's always an opening left for the stair, and that generally the architect hasn't designed the stair or worked out exactly the size to the opening before the job is let. So often the floor openings are too big or too small for the stair that's ultimately selected. I know this because Staircraft are a stair manufacturer as well as a floor manufacturer. And the reason we went into floors is so that we could take ownership of both the stair and the floor, make sure that the openings are the right size. DAISY is actually now just having put into it a stair design module, so you could actually design the staircase that you want, figure out the opening that you need for that stair, and then design the floor array opening, if you like, so the two designs are integrated. It's obviously quite fast. It can design a floor in, well, easy ones it can design in 2 or 3 minutes, and hard ones 10 to 15. But that's a lot quicker than an engineer would do, even if he's really on form. You wouldn't do it that quickly. It's generally an hour or two. So the other thing that software can do is it can work 24/7. So 3 times as many hours in the day that an engineer would generally fit for. Weekends, bank holidays, Christmas Day, it can work all the time. And so basically the productivity increase is over 100-fold, because it's not just quicker, but it's also working 24/7. It can reduce costs very quickly because it always finds the best solution. There's no chance of having a come out poor, and not well considered, and therefore over expensive. And it's looking to optimize waste, so it's always going to try and find the most cost-effective and material efficient solution. So engineers often try and minimize one or the other. It's difficult to minimize both. Often they're on a limited time, and so they have a few goes at an optimal design, and then they have to cut and run and supply a quotation. So generally they won't find the true optimum. Just to give you some idea, on a floor, a typical domestic floor, there are hundreds of thousands of different framing solutions you could adopt, and only one of them is going to be optimal. And a good engineer will try 3 or 4 and pick one which is pretty close to the optimum. But engineers that aren't experienced can often come up with designs which are, up to double the cost that they should be, and probably very material waste, not very good at material waste utilization either. It's important for Staircraft, being a mass producer, to stop both of those things from happening. They won't win enough jobs if they're inefficient at the design or utilizing waste. So it's part of our DNA that we have to minimize both the cost and the waste on anything that we supply. That's why we spend money on software development each year. Okay, so a brief introduction on how DAISY works. There are many types of artificial intelligence used in the world, and we're using one particular type called a genetic algorithm, genetic programming. Now, this actually works on the same basis that humans and animals have used to evolve, that the Darwinism principle of how species evolve over time. And the software that we use actually mimics that methodology. And it's fascinating to me as an engineer to experience how artificial intelligence can come up with solutions that experienced engineers like me wouldn't think of or couldn't find quickly. And it's also quite scary because the AI technology will effectively only consider two things in its chase to find a solution. It only has two rules that it adopts. One is that the design that it must achieve is code compliant, is structurally safe. So a check is done on any design that it comes up with that it's code compliant or it's structurally sound. And it must get a tick in that box, or else it will reject the solution it's come up with. And the second criteria that it adopts is the design that I've come up with better or worse than the one I came up with previously? In other words, is it cheaper and utilizing less waste? And again, if it isn't, it will reject it. So it's chasing a design based on two principles only. It has no other criteria, no rules other than those two things must be applied. And human beings like me over the years, we develop a set of rules that we use to find a solution as quickly as we can. But those rules are often biased or incomplete, and they don't find things that AI can find. I've seen this myself. So effectively, the way it's working is that it starts off, if you look at human evolution, for example, it starts off with what you might call a pretty poor solution. Its first guess is laughable, quite frankly, often. It's never going to work, and it's a train smash in terms of a design. It then learns that whilst that it will throw it away if it doesn't work structurally, but if it does work structurally, it will measure its cost and have a number in its head as to how much that design cost. It will then try another design at random and look at whether that's code compliant and how much that costs. And what it's doing is building up a database of what at this stage are fairly poor solutions, but they all work structurally. And they have a set of costs ascribed to them. And then what the evolutionary process does is it matches these designs up together as mum and dad, if you like, or female and male. And it produces a hybrid design, a baby, if you like, a child from those two parents, which is partly borrowing things from the male and partly borrowing things from the female. So it's joining the two designs together and coming up with a new design, which is a hybrid of the two old designs. It then checks whether that child is more or less efficient than its parents. In other words, is it structurally sound and is it cheaper? If the child is better than its parents, it basically gets adopted into the next generation, and the parents get written off or moved to one side. If the child is less efficient, then the parents are kept and they cross with other parents to effectively create new children. And this evolutionary process is one that all species use to evolve. The fitness of the children must be superior to the parents, or else the species will ultimately die out. And there's another thing that that is used in genetics, which create interesting variations, something called mutation. So what I just described when you're interbreeding candidates or pairs is something called crossover, where they're creating children. There's another side to this branch of AI called mutation, where at random a solution is pulled in, which is never been in any of the other parent solutions, but it's like an off-the-wall go at something that may work. And that is thrown into the mix as something that may introduce diversity into the species. If you don't do that, then you end up with solutions that are related to the initial population that you started with, and it starts to get a little bit incestuous. So crossover creates an environment whereby new things are introduced. Some are rejected because they're rubbish and their fitness is poor or their cost is poor. Some are kept and they introduce variety. And the software algorithm that we have is basically doing that to chase a solution. Now, to give you an idea, out of the hundreds of thousands of candidate solutions that you might get to a floor design, which would take a long time to run them all, this genetic algorithm can find a solution generally after 40 to 50 tries. So it can cut the number of candidates down from hundreds of thousands to tens or hundreds by using the principles of crossover and mutation. And I could go into a lot more detail as to how it works, because I now understand how it works a lot more. But basically, it's similar to rabbits breeding, crossing over and mutating. And the same applies to viruses and all other things, including COVID. It will be doing the same thing as we speak. It will be trying to create new variations which are more potent than the last one. So there we go. Okay, so I'm going to now run a demonstration of Daisy for you. It's with me dubbing over it, so I'm going to let it run. So I created this little 5-minute demo, and it's been created for the North American audience. So please excuse the fact that it's imperial units, but I think you'll get the gist. Hello, my name is Luke Weil. I'd like to show you the use of Daisy AI, the system that we've developed to automatically frame timber floors. So we'll start off by going into the web app Daisy, which you'll see here. You can either upload existing files from applications like Revit, if you've built your building already in a CAD system, or you can use our own CAD system internally to build the job if you need to. So let's go and create a job, give it a file name, open up our CAD system, web-based CAD system for inputting things. So we're going to put in some walls. I'm going to do a simple box. So timber frame box, as you can see. Let's put in some internal walls, change the wall type. There's some internal walls, and we're going to add a stairwell opening. Okay, so there's a stairwell opening. So you can see now that we've got this relatively simple building with a stairwell in it. We now need to assign the preferences that we wish, so we can put dimensions in metric or imperial units. Design in Europe or North America, different codes of practice, obviously. So we're going to go with North America, Canada or USA. I'm going to go for USA. We can design the floor performance to code minimum or above code minimum, up to 25% above codes. I'm just going to go for the minimum code allowance. And different centers, obviously we want to try the different options to find the optimal solution. So I'm going to keep them all on there. Okay, next thing is to define the depth of the floor that we want to choose. So there's a range of standard depths to choose from. And then we need to pick the manufacturers and the types of products we want to use. So we can design with various materials, solid lumber, engineered wood products, glulam, LVL, I-joists. I'm going to go for I-joists from, say, Pinkwood. Okay, it's found 15 of appropriate to that depth, we'll take all of those. We'll perhaps use glue lam for the beams in the floor. We could again use any engineered product we like. And again, the rim boards, we can choose, perhaps we'll choose LVL. Need to pick a manufacturer, say Trust Choice. So now we've got an LVL rim board with glue lam beams and I-joist floor. Okay. The secondary flooring, we can pick, say, 7/8 inch flooring, glued and nailed, and let's assume we've got a ceiling here, 5/8 inch ceiling. Okay, the loads, they're standard loads applied to the floor. We can change them if we like, but I'm going to go with the code loadings. We can put job reference in if we want a job. So I just want to go straight and design this floor now. So I'm going to save it to the DAISY server. Okay, that's now saved on the DAISY server. We go back into the DAISY server, you'll see here the job that we put in is work in progress. And now I can run that job. So I'm running it now, and its status is going to change to pending. It'll come up as pending in a second. Then it will go into a status called queued, and then it will start running as this job is running at the moment. And ultimately, hopefully be successful. And then we'll be able to come back and view the floor once it's succeeded. So I'll come back to you in 5 or 10 minutes after this job is run, and hopefully share the result then. Thank you. Oh, hi there. Okay, so we've now got the job back. I got an email saying that it was succeeded. So we're going to go and look at that job now. Go back into DAISY CAD. Okay, so here's the job. You can see all joists and beams, glue lam beams, I-joist floor, LVL rim boards. So that's now the job completed. It took DAISY about 5 minutes to design that job, and we can get a full requisition and price on that floor now. So thanks very much for listening. Okay, so that was a quick demo for the as a taster, if you like. It's on the DAISY AI website. You can actually go onto DAISY AI and give it a try, you know, subscribe, and you get 2 weeks of free use of it, or to give it a spin. So anybody that's interested can actually try it. At the output, you get a PDF output, which basically gives you the framing plan for the floor. The crosses there are the decking sheets, where the decking sheets land. The red ones are cut sheets and the other ones aren't. So effectively, as you can see there, there's a requisition of the materials used, the beams and the joists, the costs of the floor. So an architect, you can roughly what you're in for in terms of the costs, and the performance of the floor in terms of how much utilization there is of the joists in terms of their structural performance. So that's, in a nutshell, the output from DAISY. As I say, Staircraft are using it 24/7. It's about to be launched in America. We now want to move on and design stairs and CLT buildings, and ultimately the whole plethora of different timber solutions. But that'll take us a few years. This year, T is starting to happen, come out of the ground. Hopefully by the end of the year, DAISY will be capable of designing a CLT building, as well as the timber floors that we showed to you today. So thank you very much, and I'd welcome any questions.
Thanks, Luke. That was, yeah, no, really interesting. Oh, I love the optimization and the reduction of waste. Right, we have. So, question from Shona. Looks amazing and intuitive software. Does DAISY have an embodied carbon optimization function?
That's a very good question. We the answer is not now, but wait for about 6. I'm in charge of the development plan for DAISY, so it's my sort of part-time activity when I'm not farming. I'm managing the development of Daisy as well. And it's about 6 or 8 weeks away. It's being done. It's clearly a key component, particularly when we get into CLT. It's a given, because that's absolutely key when you get into whole building design as to what the embodied carbon or what the footprint is. So it will be done, but not quite yet. It's coming. We know how to do. We've written the specification. We know how to do the maths. We've just got to get it in there.
A fantastic and brilliant question. I mean, that's when our participants are having access to not only the Passivhaus software, so to design to Passivhaus standards, but they'll also be having the AECB carbon tool, which can plug directly into. So yeah, we're asking them to look at their embodied carbon and to exceed the REBA 2030 targets and the LETI ones as well as they possibly can for the community centre that they're going to design. So yes, using your software to design the flooring would be
Yeah, it's I-joist and timber at the moment. If you want CLT floors, we're going to struggle with that at the moment. So it's work in progress. I wanted to show it to you today because clearly it's something, it's the first of its kind. Hopefully it'll transform the way we work. We'll get timber out in the future.
Yeah, and that's so essential, with manufacturing to get the most from the forests that we have. And I'd hope tonight that we would, have a bit more on forestry. So how what architects and engineers optimize and decide to specify, how that feeds back into what we'll be planting in the future. Because with trees taking, I think, from 40 to 100 years to grow as softwoods, there's a long way between having your stair arrive next week and the next, timber that's being planted to, for the next staircase.
Yeah, I mean, the thing is that we know, working, in the manufacturing industry and the supply industry, we do know what it takes to get a building out of the ground and sequence properly, because we do it in our world, and we just have to creep up on it gradually with the software. We know what to do. We need to. It's limited a bit by time and budget, as everything is in life, but. We will get there. We're all determined to get Daisy to do the whole thing before we sign off.
And brilliant. So no retiring soon. So there's one question from Gareth. Is there plans for Daisy doing the walls and roof too?
Yes. So the plan is stairs are going in as we speak. Be ready in the next month or two. CLT. The rest of this year we want to do CLT floors, walls, and roofs. Next year, the 2023 prefabricated walls, so timber frame walls, open and closed panel timber frame, and then roofs is the final to top it off. Truss rafter roofs or loose frame roofs, I-joist or site cut roofs in 2024, and then I can retire.
I like the idea. Site cut roofs. Can I ask all our other speakers, thank you very much, Luke, to turn their cameras on, and I don't know, maybe they've also got questions for each other. Or just maybe put your finger up so we don't all just talk over each other.
I was just going to say that's why I asked the question for yourself, Luke. That's some really powerful software. So yeah, really great to see that. It's AI learning in the construction industry. So it's really cool to see that.
Thank you very much. Yeah, I'm excited about it. I wish we'd come across it earlier, but there we go.
I was quite interested in the work by Gary in WoodKnowledge Wales about making Wales a timber nation. I was wondering, how's that going so far? What's the main objectives you're working on now? And I'm personally quite passionate about timber first policies for cities. I know we're probably a long way away from that, but any thoughts on that, Gary?
Yeah, there's lots in that. Our approach is to try to demonstrate things first. So find people that are willing to do things. And what we found is by doing that and focusing on the reasons why you should build with build with timber, so low embodied carbon, high performance, those kinds of drivers, which naturally then bring a focus onto wood-based, engineered, off-site kind of high precision systems. And that has led to policy change in Welsh Government and encouragement to use wood, and an encouragement, significant encouragement to develop a timber industrial strategy that that leads to the manufacture of products as well. So, you know, you can see this big decarbonisation agenda, which isn't going away. It's massive. It's only going to gather momentum, and wood is going to be, if it's not already, seen as a key solution. But Wales will be in the situation where it will be importing all the products. And actually, the kind of trees we grow, like up in Scotland, are the spruces and pines that all these modern engineered products are made from. So it's not a massive leap to connect the forest to the demand, which the government is actually paying for, because a lot of the housing is paid for by the government, a lot of the infrastructure is paid for by the government. So there's not a lot not to like. We haven't had much success yet with the cities, it has to be said, and so our focus hasn't been CLT, because in terms of rural housing, you know, it's a tougher sell for CLT, but you know, so the sort of multi-story residential, I think we've got 1 or 2 CLT examples coming along.
Yeah, I was more curious, more from a timber and construction wider national perspective rather than CLT specifically, because just the fact that you've managed to engage with government and get them to change some things is a massive achievement. You know, keep it up.
Well, we've had a lot of luck. I mean, our climate change minister grew up in Canada amongst trees, so she gets it quite deeply. She kind of understands it, and within the climate change ministry, it's very joined up, because the environment within the climate change ministry, you've got the environment portfolio, that's all the land and the forest. You've also got the construction portfolio. So that's all the buildings and the building regulations and planning. So it's quite joined up. So we do have the potential to move quite fast, but we're starting from a low position, Mila. We're behind Scotland in the sort of forest agenda, and Scotland's behind a lot of Europe. So we've got a lot of catching up to do, I'd say.
Oh, a lot of helping each other out.
Yes, much better way to put it. Yeah.
Yeah, I like that collaboration. A question's just come in, a follow-up for Gary. What species of trees and grades of timber are Wales mainly producing at the moment? And what are you going to be looking for in the future?
Well, the most of our timber at the moment is Sitka spruce, so it's spruce. Climate's changing, tree disease. We are going to have to diversify from spruce to lots of other species, and we've just completed a piece of work which you'll find on our website, where we looked at 150 alternative conifer species to see which might be the top 5 most promising for the future. So redwoods possibly. Yeah, the forestry is going to have to become much more dynamic, reactive, and I think digitally enabled. So I think we're going to have to be able to link, take this digital tool, not start it with the CLT, but start it with the trees. But we're not quite there yet.
Yeah, and that is definitely coming, isn't it? You know, I know in Sweden and Finland, maybe some in Scotland as well. I don't know, Robert, they're obviously, you know, measuring the trees. They know what's growing. They know what potential knots and defects and the growth rates are. And then you're designing the products from the material you've got, as opposed to trying to make the material you've got fit the products that you want to make. So it's, you know, coming back to that that whole the opposite way around. There's one, Ellen, I think it's put a cheeky question in there in the thing. Is there potential for WoodKnowledge Wales and Stora Enso to collaborate?
Yeah, well, yeah, I think so. Yeah, why not? Of course not. I mean, for us, it's all about trying to grow not just the mass timber industry, the timber industry in general. We need to be using more timber in construction, and it's by working with people like Gary. We recently had a similar presentation with the Irish Green Building Council. We know Scotland has a very strong homegrown CLT agenda. In terms of having a Stora Enso based facility, we base our factories very much on sort of logistics and being close to forestry. All of our CLT is C24 grade, or at least 90% of it is C24 grade. And because of that, historically, also all of our sawmills are based in Central Europe or around Europe or the Nordics. So it depends also logistically, having a factory that is based on, for instance, the edge of Europe and then trying to transport that timber all over Europe. It's usually best to have facilities that are kind of in the middle of Europe somewhere for easy routes. But that's not to say that it's not a possibility. I know that there's been homegrown timber already produced in Scotland, and I think that was C16 grade. So I don't think there's anything to say you can't use C16 grade for mass timber. But I think it's more about, yeah, that infrastructure of forestry, making sure there's enough sustainable forestry in those countries to manage output. Typically, one of our factories makes between 70 and 100,000 cubic meters a year. So that's quite a lot of trees. As you know, we only use 30% of the tree for CLT, and the other 60% goes into other byproducts. So it's not necessarily just about having homegrown timber and a forestry network and a CLT mill. It's also about having a sawmill. It's also about having avenues to use that byproduct in other products. So it takes quite a long time to build that network. Biomass pellet factories, for example, every CLT mill we have is linked to a biomass pellet factory where our waste goes into being made into sort of renewable energy. So it's kind of it's not a short process to set up a new factory location, but for sure the amount of work that's coming in from people like Gary and the various sort of government schemes going on to increase homegrown timber, then who's to say what will happen in the future?
I think one thing that I'd like to add to that, because I've seen it happen before, and I'm predicting it'll happen again with this growth of CLT, is that it's happened with timber frame, where timber frame has expanded from a market share of 10 to 15% up to 30% and dropped back down again. There's an issue with design turnaround and design skill. Now, at the moment, we get design hubs like Urbane keep getting mentioned every time somebody's done a CLT building, or Rambol. There's a few centres, if you like, of excellence where all of this stuff goes. And to be quite honest with you, if we want to really realise the potential for whether it be timber frame, panelised timber frame or CLT, we have to not just rely on small SME specialist companies. They're perfectly capable of dealing with the demand as it stands, but they will fall over if the demand reaches what it should be. And so partly that's incumbent upon the education sector to try and teach new generations of engineers that are more capable of specifying and designing with wood competently. Partly we can get that from continental Europe, where there's a lot more expertise than there is in the UK, but partly it must be done by software. So investment, I've seen it so many times where manufacturers or sawmillers could create a great product and demand follows, and then it falls over with supply of quotations not being quick enough, or the infrastructure to deal with that not being in place. So that's where I've decided to park myself, if you like, now, is to try and help to create something which enables massive numbers of people to design with wood competently without having gone to college for 20 years and, you know, read all the books that we've all read to get where we are right now.
Brilliant, Luke. That's tied unless somebody else wants to jump in. Robert, he probably can't unmute himself now.
Yeah, I can. No, yeah, I guess as a lead into what we're doing through the Edinburgh Napier Timber Development UK NMITE partnership. So we've finished off the piece of work now in terms of creating which Mila started off on in well, she started off way before that, right? Back in Yoker, I think it was. But the timber technology engineering design competency framework, which is all about training built environment professionals of the future, such that are competent in terms of designing, specifying, managing, procuring, costing with regards to whole life value, etc. Timber. So it's very much a sort of a built environment program of work, or a built environment educational program, but with timber and sustainability at its core. In line with your thinking, Luke, as well, we're to maximise the outreach of it is to get this based in the cloud, and give those that are training access to the relevant softwares so they can use it, even if that's an educational license or whatever it may be, and take away some of the fear factor that's associated with timber in many respects. And then, of course, we need to facilitate collaboration and networking, such as the challenge that we're doing here, but equally give them practical experiences. So as much as they'll be able to access the stuff remotely, design for manufacturing, assembly and disassembly, and etc. We want to then bring them to hubs, and one of those hubs would be the Centre for Advanced Timber Technology, where they can then participate in practical challenge-based learning experiences, and do that ideally in multidisciplinary teams. So I mean, my idea would be, you might have a time served joiner, or an architectural technician, or a structural engineer that come together to participate and undertake that sort of assessment process to demonstrate that the understanding knowledge they've attained through the virtual learning environment. So that's the trajectory that we're on. But that, I think, as you say, it's trying to move this all into the digital age, and give the learners the knowledge as well as the tools, such that they can exploit the benefits of this natural renewable capital that we have, given the climate crisis. So thank you for that, for those leaving in comments.
Oh, no, and thank you all. Let me just share screen and hopefully share the right one. So I'd just like to say, a huge thank you to Gary Newman at WoodKnowledge Wales, Mila, Duncheva and Gareth Mason at Stora Enso. And I've only put you that way. It's only because Gareth, maybe before Mila, don't kick me. Luke Whale at Staircraft, and obviously Jamie couldn't join us tonight, unfortunately. And next Tuesday, we are going to be addressing timber performance in fire. And now I can't see my slides because I didn't get them up in the right place. And we're going to be joined by Andrea White, who's a fire engineer, Professor Jose Torrero Cullen, who is an engineer who deals with fire, and Martin McLagan, who will be talking about different timber products in fire. And we couldn't put this on without a huge thank you to our sponsors. So Transforming Timber talked a Tuesday ago, was it 2 Tuesdays ago? So they are making, CLT out of homegrown timber up in Scotland, and Stora Enso, one of our sponsors too. And last Tuesday, you heard from Wood for Good, PEFC, the Timber Decking and Cladding Association, Akoya, and the Passivhaus Homes, who spoke earlier in the series. But we're also supported by Rotterblas, who will do all the fixings, UFI VocTech Trust, the AECB Carbon Light, this is like the calculator, Design PH, which all the participants will get access to, and Trimble with their whole SketchUp package. So with that, I'd just like to say thank you very much for attending, and I look forward to seeing you on Tuesday.